Welcome to a series of short educational videos which describes important concept of building performance. This video will be about basics of systems analysis, and we will be using an illustrative example to point out some important key concepts and procedures. So right now I'll be speaking about two key concepts, and whenever you speak to a systems analyst, they will have their own, key concepts or whatever. And but usually these two things are accepted as important, and we always have to remember it because sometimes it's important that even like advanced system analysts they seem to forget this. So the first one is systems are not the real thing. And we learned before that the systems have some kind of a mathematical, description. So there's always a generalization at heart. So we have a generalization of the real thing. Okay, so it's not the real thing. And therefore we also have to identify and to agree that there are certain simplifications, and which we have to do. And it's not only holding us back, but it also helps us. And we should simplify, and then we should concentrate on what metrics is useful to quantify the specific system's behavior we are looking at. Because in a lot of times we would like just to quantify a specific performance metric or behavior. We don't have to look at the entire thing, so to speak, because sometimes we don't need the degree of accuracy and completeness for the particular task at hand. So in order to illustrate it, let's just use an illustrative example. So we are actually using a really funny but also very illustrative example of a bathtub. It's a system. Is this a system? And first of all, we have, what is the function here? And the function is, for us, which I describe because I'm doing the analysis, is we have to have enough warm water for a relaxing bath, right? So what we have here is it's beautiful bathroom, and there's a tub in there. So the first step actually is like we define the function which we have, and then we have to define the extent of the system. So we have to define the boundaries because do we have to model, or do we have to know about how much daylight is coming in and how much certain the towels and all things around, they actually distract. So right now we're going to the core and define the boundary of the system which we use in order to describe the function, the performance according to the function. So in order to do that, we look at it and say eliminate all the components, the environment actually around it, that are not needed to model the system. In a way, the function or the performance goal is defined. So we are looking at the entire bathroom, and we cut it off. Because we have to remember systems are described as models, which in turn represent the simplification of the real world. So after we have, now that we have defined actually what we have as our system, we have the function. Again, it's to maintain sufficient warm water in the bathtub for a nice warm and relaxing bath. And we have the elements, which are the bathtub, faucets and outlet, and we have interconnections. Interconnections, of course, is the connection to the municipal water supply, because we have to get the water. Of course, it has to be heated up, but right now we are just looking at the water. And the wastewater system, because we are discharging something. Otherwise, our bathtub would just overflow. So right now we have defined function elements and interconnections. So we go on and define what kind of metrics we have to use in order to define the performance of our bathtub system in a way the function is defined. The first one is the amount of water in the tub, because we want to be covered all with warm water. You all know, the sensation of being really nice. You just don't want that actually the water is only like 2 inches deep or whatever. So the first one is the amount of water, which is mass. The second one is the temperature of the water, because the water, of course, has to be warm enough in order to be comfortable. So this is energy. But in order to keep things very simple, at this point, we only look at the mass. We do not right now look at the energy. So right now, we look at the system, in terms of the element which we have, and the interconnecting to the exterior water supply and discharge, right? So how do they interact? We have the intake. This is the water inlet, and we have the outflow where the water actually is going out, and we have the resulting stock. And stock in a system is basically defined as how much of volume, how much of amount is actually contained in that system. So right now we come, and it's a nice picture, and it's always great if we are able to, and although it's a picture, it's still, a real depiction. And in our head, we start to perform some kind of a diagram, because diagrams are always great to understand, amount of things going back and forth, like, water in, water out, how much is in the tub. So right now we're actually looking at more of a diagram. So water in the bathtub, so this is actually our system, which is in the red, and we have interactions. We have the source of water, which is the municipal water supply. And right now the origin of the water is not relevant here, because it is just what's coming in. Okay, and then on the other side we have the sink of water. So this is the sewer system. We might be also be able to use it for irrigation, and the high performance and green buildings. We should really not waste water in a sense, giving it all to the sewage. It is also possible at certain codes just to use it for irrigation. But again, in this particular case, the destination of the discharge water is not relevant here, because we're only defining the system, and we have, of course, the interaction. Here we have the inflow, which is regulated, and we also have the outflow regulated. So this determines or just shows the basic system process diagram. So once we have the diagram, the next step will be to develop a schematic abstraction of the dynamic behavior of the system, because we already told that we have an inflow and an outflow, and the inflow and outflow has some kind of a dynamic influence, a dynamic process on the stock of the system, which is the water in the tub. So this one, actually, the illustrative scenario number 1, says we only have outflow. So right now you see on the right side is the outflow. And we know that the system, or we can identify that the system stock, or the water in the bathtub, follows the dynamics of input and output. So here we actually have outflow. All right, so this is only outflow. We don't have any inflow, and we see that the water in the tub at the beginning it was high. Then since we only have an outflow, water level goes down. You might say, well, this is very intuitive. Why actually are we going, to have such a simple mass flow or scenarios? It is always important to come with a very simple idea in order to get a good handle. And I would really encourage you, when you have system analysis, you have to understand even simple dynamics, simple processes. And only then you go forward. Here, for instance, we can stipulate if the sum of outflows exceeds inflows, then the level of stock falls. So let's go to the second illustrative scenario, which is a little bit more complicated. So what we have here is we have an inflow and an outflow, and we see we actually are regulating it. Here's the outflow, it's in red, and the inflow is in green. And on the other side, the water in the tub is that it follows some kind of behavior there, and we regulate it such the inflow and outflow that the water level in the tub is always between a certain minimum and maximum. And this actually is a dynamic regulating of input and output, and that counters the deviation from the desired level, because the desired level is that we have enough water, but of course it cannot be too much water, and since otherwise it would overflow. And the reason why we put water in and let some other water, flowing out of the tub, of course, is to maintain a temperature. So this concludes our very basic and system analysis. And it's always good to go down to the basics. And once we have seen that, we can go further. So this actually concludes our discussion. And right now, let's see how much you remember. And this, again, what we always do is a self-learning assessment. And what are the two key concept systems which we have looked at? What do you think about the illustrative example of the bathtub? It is very simple, and it, what does it have to do with building performance? In regard to the flow of mass, what determines the stock of the system? Which means the amount of the system in the bathtub. These are three basic questions. It's always great to ponder it and try to ask yourself and then come up with an answer. And if you need, you can go back and look at it again. And if you think you have to do more research, just do that. Answering these questions, these self-learning assessment questions, will greatly help you to understand the concept much better. So we thank you for your interest, and we would like to invite you to join us again in the future. Well, thank you very